So here we have imported all the libraries. First one is the SMFs library that helps us to find the sample size of our code. After that is the starts model dot API, which is considered as SM. This is the API which will directly give us the z-score value and the p-value, and I will explain that later in the part of this code. And then we have the pandas library and the numpy library, which are very important. Then is the scipy import stats as st. This particular library will help us to do the hypothesis testing, and after that we have the matplotlib and the seaborn. This two library particularly will help us to get the data visualization part. After that we have the main code. Here we starts the main code. Here alpha is equal to 0.05, so significance is 0.05, that is the 5% significance. I will explain you with the help of a diagram. So here alpha is equal to 5%, and this sample diagram or the sample graph is one-sided graph. So there is another graph which is the two-sided. I will explain it, but now for this we have 95% written over here, which is the null hypothesis, and this represents the set of customers that are using our old credit card. And here this part of the graph will represent the transaction done by them using the old credit card. And after that we have the 5%, that is the alternate hypothesis. This part of the graph represents the transaction done by the new customers using our new credit card. And after that we have power. So in the code we have considered power is equal to 0.8. So basically power starts from 0 to 1. If the power is nearer to 0, then its effect will be much more higher, and we can get if the null hypothesis is lying. Then is effect underscore size, which we have considered 0.2. So this basically helps us to get the sample size. After that we are using the imported library SMS. Here effect underscore size is equal to 0.2, and then we are putting the alpha value and the power, and here ratio is equal to 0. This is something new here. So ratio is equal to 0 means if we are getting, suppose 100 is our sample size we are getting as output. So if we are writing ratio is equal to 0, then the 100 value will be equally divided between the two groups, that are the test group and the control group. And next it is written alternative is equal to two-sided. So I have to explain you this with the help of a diagram. So now two-sided, this one is the two-sided. The above one was one-sided, now it is the two-sided. The difference is that the alternate hypothesis here is 5% and written in one side of this graph. But now the alternate hypothesis is divided into two, and we get 2.5, 2.5. The one of the alternate hypothesis will be written in the left side and another one will be written in the right side. So the middle one, that is the 95%, is the null hypothesis, and the line perpendicular to the x-axis is the mean. Now let's return back to the code. Here we have as output is the 393. So this is the sample size which we are getting. But we cannot consider this sample size and do our testing with this. We have to discuss this with our business manager. Once we discuss this with our business manager, we get information that we have a budget restriction, so we cannot consider 393 customers in both the groups to conduct our test. So we make a list of all the effect sizes. Here we have 0.1, 0.2, 0.3 and all, and we will put all the effect sizes in a for loop and get the sample sizes for each of the effect size. Now we will consider only one of the among this, that is the effect size is equal to 0.4, and for that our sample size will be 100, approximately 99, 100. But when we take this to our business manager, see, consider this one, and we have to do our hypothesis testing using 100 customers. But there is a restriction to it. Only we get a conversion of 40% from it. That means we have 40% of our customer in the test group and another 40% of our customer in the other group. So you can pause the video and read this part, because here it is written what we'll be proceeding with. Now we have a CSV file that we have imported here, and we use df.head4. So first 4 rows are written over here. So here we have the index column, the campaign date. Here the dates are here. Then we have the control underscore group underscore average underscore transaction. So the transaction made by the control group, and the other column one shows us the transaction made by the test group. So this is the data frame, and using the df.sep we can see that we have 62 rows and 3 columns. So you have 62 rows and 3 columns, and we have done next is a data visualization. One of the data visualization show the control group average transaction, and the other one shows us test group average transaction. I'll give a bit explanation of this data visualization part. So here we are using here Seaborn library, and we have printed a hist plot. We used here df data frame, and inside that the control underscore group underscore average transaction. So we are using the control group average transaction part. And when you are doing KDE is equal to true, so this line is coming. You can see here this line is coming. After that we have color is equal to sky blue. So this bars over here are sky blue, and you can see the bar over here are green, light green in color. After that we are specifying the label. It is written over here, and similarly the other one is also done. And then we are doing the plt.show, and we are getting our data visualization. Then now is we have to do perform the hypothesis testing using the two sample z test. Now for the control group we'll find the mean and their standard deviation. You can see we have taken a variable contour underscore mean and made it equal to df, and inside that df we have written the column, and then we have done dot mean, which is an inbuilt function, and similarly std, which is the standard deviation function. And by getting doing this we have printed our mean and standard deviation value for the control group. Similarly for the test group we have done. So I hope you understand this part. And then we are getting the sample size. Here it is 62. Before I have mentioned that df.shape, here it is 62 and 3. So we have a sample size of 62, means our total rows in our data frame is 62, and that is the sample size. And then we'll do the test using the rejection region using the critical Z value. So before finding the critical Z value we need the Z score value, and here is the formula for that. So we have to do Z score is equal to test mean minus control mean divided by the square root of control underscore std, the control standard deviation whole square, by sample size, and then adding this with the test underscore std whole square divided by sample size. In this way we are getting the z score value. After that, though we have now our z score value, and then we have to find the critical z value. The critical Z value is a threshold, means it acts as a borderline. If the Z score value crosses it and falls in the alternate hypothesis region, then we are rejecting our null hypothesis, means we are rejecting the old credit card which is being used by our customer in the control group. And I will give you example that why our new credit card is working fine, you can see that here control mean is equal to 221 and our test mean is equal to 235. So this shows that the average transaction made by the test group, the customer in the test group is higher. So this shows that our test is passing. So now we get a critical Z value and we are getting 1.644. So this is the threshold value which acts as a borderline. So now we have our Z score value and critical underscore Z underscore value. So after that we are comparing between them. Since our Z score value is greater than the critical Z value, so we are passing our test. That means we are rejecting the null hypothesis. So here it is written, since the Z score value is higher than the critical Z value, so we can reject the null hypothesis. That means our new credit card is working fine. So this is the test using the rejection region with the help of critical Z value. And similarly, the test can be done using the p-value. So the formula to find the p-value is 1 minus st.norm.cdf, and inside that we will put our z-score value. So we are getting our p-value using only the z-score value. So after we get our z-score value, we will compare it with the value of alpha. So before I have mentioned that alpha is equal to 0.05, that is the 5%, and here p-value is 0.00299 and so on. So here we have p-value is less than the significance label, that is the 5%. Since the p-value is less than the significance level, so we can reject the null hypothesis. So in using the test, using the p-value is also passing. That means our new credit card is working and it is fine to be published. So now we have our z-score value and critical underscore z underscore value. So after that we are comparing between them. Since our z-score value is greater than the critical z value, so we are passing our test. That means we are rejecting the null hypothesis. So here it is written, since the z-score value is higher than the critical z value, so we can reject the null hypothesis. That means our new credit card is working fine. So this is the test using the rejection region with the help of critical Z value. And similarly, the test can be done using the p value. So the formula to find the p-value is 1 minus st.norm.cdf, and inside that we will put our z-score value. So we are getting our p-value using only the z-score value. So after we get our z-score value, we will compare it with the value of alpha. So I have mentioned that alpha is equal to 0.05, that is the 5%, and here p-value is 0.00299 and so on. So here we have p-value is less than the significance label, that is the 5%. Since the p-value is less than the significance label, so we can reject the null hypothesis. So in using the test, using the p-value is also passing. That means our new credit card is working and it is fine to be published.